we've been given two particles. One is P, and for P, we've been given the position function. So it's expressed as x of P of T, and it's a log function. And we've been given another particle Q, but the Q function, the Q particle, that we've been given the velocity function. So part A asks for 0 to 8, when is particle P moving to the left? So what I need is velocity. So I'm going to need to differentiate that x function to find out the velocity. And if the velocity is positive, it's moving to the right. If the velocity is negative, it's moving to the left. So that's the first thing I'm going to do, is I'm going to differentiate that x function. I end up with, since it's a log function, we're going to get 1 over t squared minus 2t plus 10. And because it's an embedded function, we need to apply the chain rule. So we get 2t minus 2. Now the denominator is non-factorable, so it doesn't really simplify. So I'm just going to simplify this as 2t minus 2 over t squared minus 2t plus 10. And I want to know when this is equal to 0. So that would be the boundary between positive and negative. So I could just look at the numerator. So I end up with 2t minus 2 equals 0. So t is equal to 1. So at t equals 1, I know it's gonna change direction. So I need to test the left side and right side. So I'm going to test 0. X prime at 0, we're going to end up with negative. So we know at 0, it's going down, or sorry, it's going to the left. And for x prime at 2, we know that that's going to be positive, so it's going to be going to the right. Okay, so in this case here, when is particle P moving to the left? Well, we know that the domain is going to be 0, 0 to 8. And in this case, so from 0 to t equals 1, we know it's going to be moving to the left. Okay, since the slope, the derivative is negative. For part B, it says for 0 to 8, find all times at t which the two particles are moving in the same direction. Well, again, what I want to do is I want to use the derivative, or the velocity function. So I've already been given the velocity function here. So I want to know when the velocity is going left or right. So in fact, I'm going to change my slope chart here, and I'm going to just give it kind of arrows. So it's going this direction here and this direction here. Okay. And so I want to find the 0 for that velocity function. So I have the velocity function is t squared minus 8t plus 15. We want to factor this because we want to make it equal to 0. So t minus 5 and t minus 3. Let me just clean that up a little bit. That's 5. So we know we have zeros at 3, t equals 3, and t equals 5. Okay, so at t equals 3, right about here, and t equals 5, right about here, we know we have change of direction. So we're just going to do a test. So t at the q function, so the v function, v of q, at 0, when we plug 0 into that, I'm going to end up with positive. So I know I'm going to the right in this direction. Okay, at 4, when I plug 4 into that function, I get 16 minus 32 plus 15. So that's going to be negative. So I know it's going to go in this direction. And then VQ at 6, when we plug 6 into there, we get 36 minus 48 plus 15. That's going to be positive. So we know it's going to be moving in this direction. Okay, so find all the times which the particles are moving in the same direction. Well, they're going to be moving in the same direction. So if I take a look at from 0 to 3, it's moving to positive. It's moving in the positive direction for both graphs. So I can see from 0 to 3, in both circumstances here and here, they're both moving to the right. Okay, so I'm going to make a note of that. From t equals 3, so the domain is going to be from 0 to 3, both are moving to the right. Okay, and then we also can see that from 5, okay, 3 to 5 is moving to the left, but from 5, it's still going to be moving in this direction. So from 5 to 8, it's going to be moving in the same direction. So from here and here, again, they're both moving to the right. So from 5 to a domain boundary of 8, again, they're both are moving to the right. If we look at the mark scheme for this, for part A, we just have to find the derivative. We want to find the 0 for the derivative and then find the interval. For part B, one mark is for the intervals, okay, finding the different intervals, positive and negative intervals, and analysis of when V of P and V of Q are moving in the same direction. And so we can compare the two intervals and we get the final solution of when it's going to be moving to the right and when both are going to be moving in the same direction, which in this case would be right.